GMAT all day.
In this next set of videos, we will be focusing on triangles. So we are in this first section of our cheat sheet, and we should cover most, if not all of these topics, and anything we don't get to, we can just make a summary video at the end and I'll tack it on there. So let's start with our basic properties of triangles. So what is the relationship between the side lengths of a triangle? So a triangle has 3 sides, and you should know that. And you should also know that the sum of any 2 sides of a triangle must be greater than the length of the third side. Very important. They cannot be equal to. The sum of any 2 sides of a triangle must be greater than the length of the third side. So they might give you a triangle that looks like it is possible for that triangle to exist, but if it does not fit these criteria here, it is actually an impossible triangle and would not be able to make it. The relationship between the side lengths and angles of a triangle. So what does this mean? So the relative size of the side lengths corresponds to the size of the angles opposite those sides. Relative size of the side lengths corresponds to the size of the angles opposite those sides. So what does this mean? So say I have a triangle that looks like this, and I say I have an angle here that measures 100 degrees. Then let's say this guy here is 50 degrees, and this guy here is 30 degrees. So this actually touches on our third rule here. The sum of the angles of a triangle must be 180 degrees. So we can fill that guy in. So say I have a triangle like this, and then I tell you the side lengths for my triangle are 4, 10, and 7. And then I say, well, now label this triangle for me. Where should these side lengths go? So the longest side must be opposite the biggest angle. So this 10 would have to go over here. And then our middle side length, which is the 7 right here, that should be opposite the middle angle, which is our 50. So our 7 would have to go over here. And then our 4 would have to go over here. And we can check our rule to make sure the sum of any 2 sides of our triangle must be greater than the length of the third side. And so 7 plus 4 is 11. That's greater than 10. 10 plus 7 is certainly less than 4. And 10 plus 4 is certainly more than 7. So if I change this here to 3, this triangle is no longer possible because 7 plus 3 is equal to 10. So don't fall for that. And then lastly, we got the area of a triangle. And so the area of a triangle is 1/2 base times height, which I'm guessing most of you probably know. But the one thing that you have to remember is, so if you are used to using this formula, it is usually because they tell you that you have a right triangle. So with a right triangle, it is easy to find the base and the height. This guy here would just be the base. This guy here is the height. It's easy to use this formula. However, this is not the case for all triangles where it is so easy to find the base and the height. Because remember, a height must be a line that is perpendicular to your base. So you can call whatever you want the base. The height then just has to be a line that is perpendicular to it. So if I wanted to use 1/2 base times height for this triangle right here, well, it's not as easy as when I have a right triangle. Because say I want to call this guy my base, well, I can't say this is 1/2 4 times 7 because this side here is not a height necessarily. So the height of this triangle would actually be this imaginary side that you would have to add. Because if you extend this base here, that's how you get a line perpendicular to it. And so I'd have to somehow be able to find that height, assuming we want to call this the base. Or I can try doing something like calling my side here, my 10 the base, and then all of a sudden there I would have a height that looks like this. And so I would have to be able to find that guy. So this is the formula. It's a simple formula, but remember, it's not always so simple to necessarily find both a base and a height. unless you have a right triangle, then it's easy. But you cannot assume that you always have a right triangle. And so we will talk about that too. So let's do a question involving our basic properties of triangles. A triangle has legs of length 5, 12, and x. Which of the following could be the value of x, okay? And so we got a triangle that looks like this. We got some side 5, some side 12. What is the possible value for a third side, x? So let's start maybe with our actual non-radical numbers first. So let's start at our second one. Is 7.5 possible? So if x is equal to 7.5, 5 plus 7.5 is 12.5, which is just barely greater than 12, so that works. 12 plus 7.5, remember, so we have to check all three combinations. 12 plus 7.5 is definitely bigger than 5, and 5 plus 12 is definitely bigger than 7.5. So 7.5 seems to work, and so anything without a 2 can eliminate. So A is out, and that is pretty much it. What about 17? Is that possible here? 12 plus 5 is equal to 17. And so this violates our rule. The sum of any two sides must be greater than the third. So anything with a 3 in it is out. E is out. D is out. And we're just left between B and C. So 4 rad 2. What is 4 rad 2? Well, two things you should be able to estimate are the only square roots other than perfect squares are the square root of 2 and square root of 3. Those are worth just sort of knowing. And so the square root of 2, and these are each approximate. We need your squiggly equal sign, is approximately 1.4. And the square root of 3, it also comes up sometimes, is approximately 1.7. So this means 4 rad 2 is approximately, what's 14 times 4? 56. And so this would be approximately 5.6. And so 5 plus 5.6 gets me to 10.6, which isn't really even that close to 12. So even though this is an approximation, I think it's good enough, since that would be equal to 10.6, to say that even if we used the precise value, we would still not be close to 12. And so statement 1 does not work because 5 plus 5.6 is less than 12. So C is out, and we're left with B is the only one that works.